Have you ever seen an apple fall from a tree? It falls straight down, pulled by an invisible force. Now look at the moon. It hangs in the night sky, seemingly unaffected by the same force. Why does the apple fall, but the moon stays distant? The answer lies in a fundamental force that governs the universe: gravity. Gravity is the invisible glue that holds everything together, from the smallest particles to the largest galaxies. The apple falls because gravity pulls it towards the center of the Earth. But the moon also experiences Earth's gravity, so why doesn't it crash into us? The reason is that the moon is also constantly moving, orbiting our planet. This movement, combined with the force of gravity, creates a delicate balance. Gravity is a universal force, present everywhere and affecting everything. The quest to understand gravity has captivated thinkers for centuries. Long before we had telescopes or spaceships, ancient philosophers pondered the nature of this mysterious force. The ancient Greeks, for example, believed that everything in the universe had a natural place. They observed that objects like rocks fell to the ground while fire seemed to rise towards the heavens. Heavy objects, they reasoned, sought their natural place at the center of the universe, which they believed was Earth. Lighter objects, like air and fire, sought their place in the heavens. However, the Greek understanding of gravity couldn't explain everything. Why did the moon, a seemingly heavy object, remain suspended in the sky? These questions remained unanswered for centuries. It wasn't until the 17th century that our understanding of gravity took a giant leap forward. Enter Sir Isaac Newton, a brilliant English physicist and mathematician. Legend has it that Newton was inspired by watching an apple fall from a tree. This simple observation sparked a revolution in scientific thought. Newton realized that the same force that pulled the apple to the ground was also responsible for keeping the moon in orbit around the Earth. He called this force gravity and proposed a groundbreaking law to describe it, the law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. In simpler terms, the more massive an object, the stronger its gravitational pull. Newton's law provided a mathematical framework for understanding and predicting the motion of planets, moons, and other celestial objects. Newton's law of gravity was a monumental achievement, but even his genius couldn't explain all aspects of this fundamental force. It wasn't until the early 20th century that another scientific giant, Albert Einstein, provided a more complete picture of gravity. Einstein, in his theory of general relativity, proposed a radically new idea. Gravity is not a force acting at a distance, but a curvature of space-time caused by mass and energy. Imagine space-time as a giant trampoline. If you place a bowling ball on the trampoline, it will create a dip. Now, if you roll a marble across the trampoline, its path will curve as it passes the bowling ball. This is similar to how Einstein described gravity. Massive objects like stars and planets warp the fabric of space-time, creating a gravitational pull that affects the motion of objects around them. Einstein's theory also predicted that gravity could affect not only matter but also light itself. Gravity's influence extends far beyond falling apples and orbiting moons. It's the invisible architect of the cosmos, shaping the universe from the smallest to the largest scales. Here on Earth, gravity is responsible for keeping our feet firmly planted on the ground. It's what gives us weight and makes objects fall at the same speed regardless of their mass, disregarding air resistance, of course. Gravity also plays a crucial role in the ebb and flow of ocean tides. The gravitational pull of the moon and the sun tugs on Earth's oceans, causing them to bulge outward on opposite sides of our planet. These bulges create the high tides we experience twice a day. Beyond Earth, gravity governs the intricate dance of planets around stars. It's the force that holds our solar system together, keeping the planets in their orbits. At a larger scale, gravity is the driving force behind the formation and evolution of galaxies. Despite centuries of study, gravity remains one of the most enigmatic forces in the universe. Many mysteries still surround this fundamental force. Unifying gravity with the other fundamental forces is a key challenge. A unified theory would provide a complete description of all forces. Black holes are cosmic enigmas that challenge our understanding. Manipulating gravity could revolutionize space travel and energy. The quest to understand gravity continues to this day. Gravity's influence extends far beyond the grand scales of the cosmos. It plays an integral role in our daily lives. From the moment we wake up, it keeps our feet firmly planted on the ground. It governs the flow of water in our rivers and the stability of our buildings. Even our bodies have evolved to function optimally under Earth's gravitational pull. In the realm of technology, gravity aids in satellite navigation, weather prediction, and even the functioning of our smartphones. Understanding and harnessing gravity has allowed us to achieve feats like launching rockets and exploring distant planets. As we continue to unravel its mysteries, gravity remains a constant silent force that shapes our existence in ways both seen and unseen. If you liked this video, please subscribe to our channel. How do you think gravity shapes your daily life and the universe around us? Let us know in the comments below.